Chapter 4 is about chemical reactions and chemical quantities, and I really enjoy this quote from Linus Pauling. He did a lot of cool things during his life, but one of the things he was very interested in was vitamin C and its effect on health. So he said, "I feel sorry for people who don't know anything about chemistry. They are missing an important source of happiness." You may or may not agree with that, but I agree with him. I think it's beneficial for everyone to know some chemistry. Okay, so this chapter opens with discussion of the greenhouse effect. Now, I'm not going to test you on this, but I think we can all agree that the greenhouse effect, climate change, is an important topic currently in the world. And chemistry helps us to understand what this is all about. When we have some understanding of science, then when we read articles in the newspaper or see stuff on TV, we are more able to decide, is this worth thinking about, or are they just sensationalizing stuff? Should I be concerned, etc.? So the greenhouse gases in the atmosphere serve a very important purpose. They allow sunlight to enter. The sunlight warms the surface, and then those greenhouse gases prevent some of that heat from escaping. So essentially, it's like a blanket. They're called greenhouse gases because they act like the glass of a greenhouse. A greenhouse is used to raise plants when the outside temperatures aren't warm enough. And yet the greenhouse often is not heated. But the sun shines through the glass, warms up the inside, and then because it's enclosed, much of the heat stays, and so the inside of the greenhouse is warmer than outside. So the balance between the incoming and outgoing energy from the sun determines the Earth's average temperature. And the average temperature is really, really important. If it gets too low, we'll go into an ice age. If it gets too high, well, all you have to do is read the news and they'll tell you all the horrible things that could happen. Any questions yet? So global warming is a concern. Scientists have measured an average increase in the temperature of the Earth of 0.7 degrees Celsius. That increase occurring since 1860. So here's the global temperature graph. The temperature deviation from baseline. So we see that it's the baseline here is at 0, and here in the 1800s, 1900s, it was below, and then it went above, and then we do see this looks like a very dramatic increase here. So the thing about data is that you can kind of twist it and stretch it and pull it and make it appear to say things that it doesn't say. So this graph looks pretty disturbing, doesn't it? Like, oh my goodness, we're going off the charts. And I'm not saying that we should not be concerned about this, but what is the scale here? The scale is from 0 to 1 degree Celsius. Over how many years? A lot of years, right? So if this graph was done with a different range of temperatures, it might look completely flat. Now, is that correct? No, that's not correct either. But we can't just accept pictures that are given to us. We need to be critical and think about some of these things. So they've also measured atmospheric carbon dioxide levels. Carbon dioxide is one of the greenhouse gases. And here we have carbon dioxide concentration in parts per million as a function of the year. Again, going over that same time period, it's gone from below 290 up to over 400 parts per million. And we see a trend here that seems to match with the trend of the temperature. And so the question is, are these two trends causal? Meaning, is one trend causing the other trend? You cannot determine that just by looking at the data. It appears that that might be the case, and the theory is that a lot of people hold is that this increase in carbon dioxide concentration is causing an increase in global temperature. I'm not saying that isn't true. I'm really kind of on the fence when it comes to global warming. I have a lot of other stuff going on in my life, and this is just not one of the most important things for me to spend my time figuring out, right? So I'm just kind of in the middle. Because the fact is that the average temperature of the Earth is not always the same. We see it went up here and then it started to come down. And if we were to look at millions of years, what patterns would we see? How far up did those rises go? How far down did they go? The thing is, we don't have data from a million years ago, right? Because people didn't have a way of measuring temperature if they even thought about temperature. The other issue is how are these average global temperatures measured? I don't know, but I have a guess. My guess is that they're taking temperatures from multiple places around the globe over the course of the whole year and averaging them. Now, could some of those weather stations be malfunctioning or be influenced, say, by a building nearby? Who knows, right? So when we see data like this, we have to think about the uncertainty in the measurements. Now, it would be from averages, so that helps with some of the error, but still, we're looking at a small difference here, and so we need to at least question. Anybody have any comments, questions? So where's the CO2 coming from? One source is combustion of fossil fuels, right? And that's the one we're the most concerned about. There are other sources, though. Volcanic action also puts a lot of CO2 into the atmosphere. So how can we tell whether global warming is natural, due to the volcanic action, or due to man, due to our use of fossil fuels? Well, if we understand the chemical equations that describe fossil fuel combustion and how that combustion relates to the amount of carbon dioxide that's released, we can estimate how much carbon dioxide is generated from the combustion of fossil fuels. And then we can compare that to what's given off by volcanoes. Now, measuring that is a completely different topic, and we're just going to take a value that someone else figured out.